everything is running perfectly smoothly in your network. You have switch 1, currently the root bridge of VLAN 10, and the active forwarder for group 10. So this is the traffic flow right now for users in VLAN 10. But let's say this link right here fails. If this link fails, Spanning Tree Protocol sees that the topology has to change. And based on this change, VLAN 10 traffic is now going this way. However, how does HSRP react to this failure? Well, it all depends on this link right here. If this is a layer 2 link, then the hello packet continues to go back and forth between switch 1 and switch 2. And since the hello packet keeps going back and forth between switch 1 and switch 2, switch 1 remains the active forwarder. So traffic will flow like this. And that's okay, because we are in a failover scenario right now. If this link happens to be a layer 3 link, then that hello packet would not be flowing back and forth. So therefore, with the absence of the hello packet in that scenario, traffic would end up flowing this way because switch 2 would take over as the active forwarder for group 10. Also, a perfectly acceptable scenario. What if the entire switch fails? Kaboom! It goes up in smoke. It gets rebooted. Well, then the hello packet ceases to exist between switch 1 and switch 2. Switch 2 takes over as the active forwarder, and traffic flows this way. Perfect! I am happy with all of these scenarios. Everything is good so far. But what if this link fails? Do you ever think of that? What if the uplink fails between switch 1 and the core? Does the spanning tree topology have to change? Nope. Is there still the hello packet being exchanged between switch 1 and switch 2? Yeah. So who is the root bridge right now for VLAN 10? Switch 1. Who is going to remain the active forwarder for group 10? Switch 1. Meaning, this is our traffic flow. And then it gets, what? Dropped. It gets dropped. Because there is no way for switch 1 to route that traffic to the core. If this is a layer 3 link, though, if this is a layer 3 link, then between switch 1 and switch 2, they would be able to converge their layer 3 protocol. So let's say you're using EIGRP. Now switch 1 would point to switch 2 as the next hop to reach the destinations in the core, allowing VLAN 10 traffic to be sent to switch 1, routed to switch 2, and then sent out to the core. But that would only be true if you had a layer 3 link. But if you have a layer 2 link, switch 1 ends up dropping the traffic. So what can we do in order to prevent this scenario from occurring where switch 1 drops the traffic? Well, we have to teach HSRP about how to keep track of this uplink. And this is done through HSRP interface tracking. So this is a built-in feature to HSRP. Notice in our scenario, R2. R2 is currently the active forwarder for the group. So traffic right now is flowing from PC1 up to R2, and out it goes. However, if if the link right here, Ethernet 0/1 fails, what is going to happen to the traffic? Well, R2 is still the active forwarder. It has the better priority. And the hello packet's still going back and forth between R1 and R2. So traffic, as we've just described, comes up and gets dropped because R2 can't route it. So with interface tracking, we have the ability now to tell R2 that if this link fails or goes down or the interface is shut down, lower your priority. Lower your priority. So right now the priority is 110. So by configuring interface tracking, we tell R2 that if this interface fails, lower your priority to 90. And by doing so, when the hellos are going back and forth between R1 and R2, R2 is now telling R1 its priority is 90. And when R1 sees that it has the higher priority now and preemption is enabled, it takes over the active role. So now traffic is simply going to go this way. So interface tracking is all about teaching the router to monitor the status of an interface, and if that interface goes down, to decrement the local priority. And by decrementing the lower priority to a value that is less than the other routers in the group, you are thereby allowing another router to become the active router and forward the traffic for those end users.